Hello and welcome to our webcast today from mapping artifacts to a managed mapping lifecycle. I'm Sandrine Wagner, Digital Marketing and Campaign Manager at Seeburger, and I'm here with my colleagues Markus Dörner, Head of Customer Mapping Service, Global Mapping Management, and Carsten Matitza, Integration and Data Mapping Specialist. Just a few organizational things before we get started. Your microphones are all on mute. But you can drop your questions anytime in the comment box, and we'll come back to this after the webcast. Also, you don't have to take any notes. Everything will be recorded, and you will receive the presentation slides as well as the recording after this via email. Then I hope you enjoy, and I'll hand over to Markus.
Thank you very much, Sandrine. All right, so good to have you everybody on board to this webcast series, to this BIS Hub webcast series. Today, all about mappings and mapping artifacts in the life cycle. My name is Markus Dörner. I'm with Seeburger for 18 years now, and ever since I've been in the area of mappings. And therefore, my personal goal is to at least make mappings as hot again as the weather is currently in Germany. So we want to make mappings again a little bit more transparent and bring it to the table with some central tools on it. Today, I brought with me from my team, Carsten Matitza. So yeah, Carsten, a couple of words from your end before we start.
Hello, also a warm welcome from my side. My name is Carsten Matitza. I've been with Seeburger since 2013. I started here as a student and ended up at some point in the mapping management and stayed here. And today we will show you the latest developments, not only in regards to the data-driven mapping approach, but also the current web-based implementations for both the repository service and the mapping service. And we'll give you a brief outlook on what is currently being done and what is more to come. But that will be the next hour. We'll cover different topics, and I guess Markus will start with some slides first.
Absolutely. I'll try to keep these slides as limited as possible. We'll mainly focus on the demo today to bring you closer to the
1
current
second,
state.
you haven't shared your screen yet. We can't see your slides.
Oh.
Thank you.
All right. So today I'll focus mainly on the demo part, so to make it as interesting as possible for all of you and to get a glimpse on what is already possible today. But we will now start with the challenges today. And what I've already mentioned is mappings sometimes tend to lack a central and cloud accessible platform to provide a couple of things. So, I mean, mappings are code, mappings is software, and deserves to be seen as such. However, in the past, it is quite intransparent and lacks a lot of capabilities which they actually deserve, and transparency, governance, proper versioning, testing, and deployment capabilities. All of this is already there as of now today within Seeburger, but not as a unified service. And we have challenged ourselves to make this way more accessible and as it used to be in the past, and not only make it more accessible, but as well add a whole other user group to all of that, which is citizen integrators. So we now have to bring together a lot more the business as well as the developers itself. In order to do so and to have a real managed mapping lifecycle, two key factors are needed. And one central one is now our so-called BIS mapping repository service, which is a value-added service we will deliver within our BIS Hub. So this is accessible for all our customers, not only the ones being in the iPaaS full managed service, but as well from cloud to ground, even on premise. here we do approach a centralized repository, which is available and relieves a lot of customers of ours of the burden to run such a repository, take care of versioning, maintaining, and hosting. In addition to that, this will be our central service for all future values we will add to this. First and foremost, it will be a mapping code analysis. So what we are doing here is we make code transparent. So we'll put code into your hands. We will not hide it from you. It's your software, it's your code, and deserves to be as such. And therefore, we will make it as transparent as possible. But not only we will make it accessible and visible, but as well we will make it accessible in a sense of editing. Therefore, we have a web-based mapping tool in place we can use to test, to exchange, and to run and edit mappings via the web with a very easy and low access hurdle. In addition, further services like QA services for mapping code, all of that will be added all on top of this service, as well as the interface for AI-generated mapping, which Carsten already mentioned, the so-called data-driven mapping generation. The first service, which we have already available and bookable as of 1st of July, is the BIS Mapping Designer service. This allows now to create and edit mappings in the web in a very easy to access web environment, and does not require a local installation, which currently is even harder for all of our customers due to governance of IT, security constraints, and even maintenance then. In addition to this, we have a central AI capability, which we can roll out to various parts of our software, being the analysis, being assistance, being AI generation. All of that we can actually have centrally available for you as a service. In addition to that, based on our current implementation, things like an auto creation of mappings, suggestion capabilities, a recommender, language server rec, all of this can and will be added within the web-based mapping designer service. And of course, it is fully compliant with our BIS mapping designer and BIS mapping engine, which we have in place for quite a lot of years already. And therefore, it is more or less the same. It is the same code base, it is the same engine, and it's just a web version of it. The mapping repository and the designer service have a couple of goals we have mainly achieved already, which is, for example, of course, enabling XML, JSON, all the well-known formats we are already supporting in our local environment in the so-called FAT client, the BIS mapping designer, and having the repository with versioning and controls as such available. All of this will be accompanied by an integration asset catalog, for example, like mapping templates, mapping schemas, so messages to read and parse or write data in a mapping. All of that can be accessed not only from the web mapping designer, but as well from your local BIS mapping designer as well. So these endpoints are available for you. You can connect via your local FAT client if you have it already, or you can log in using the customer portal of Seeburger to access the web one. Later on in the demo, I will share how to access and how to use it. The mapping designer or the designer service as such is a schema-aware mapping. So we are heavily relying on the schema, but not limiting to the schema, where we are then overlaying data we read, we parse, and we write into the target tree to make everything as transparent and easy accessible as possible. As well, we have the broad format support like I've mentioned already, XML, JSON, Edifact are in-house and such. And we want to have reusable mapping components. So not only creating mappings, but reusing mappings, reusing suggestions from existing mappings. All of that will be part within the SIA, which is our local, our cloud-based AI assistant, which has a context-sensitive interface to the mapping designer. This one is already available in our IWS Integrator Workspace already and will be rolled out shortly into the web-based mapping as well. In addition to that, we not only have the editing capabilities, but as well testing and tracing, all of that with a centralized governance of a versioning and deployment zip creation. All right, so that has already been the introduction to the tooling as such. Within the demo, we will now focus on, first of all, the web-based area part. So the part of the services which we have web-based. Then I will create a repository. I will create a mapping project. And after that, Carsten will take over and he will connect to the same repository from a local client, from the FED client, and then do a mapping, perform a mapping creation using AI, upload the mapping again, and I'll then take over again from the web to edit the mapping and finalize the last bits and pieces. All right. Now, let's move on. Within our cloud portal, you will see, within our customer portal, you will have now a new option once the service is booked, which is the so-called mapping designer service. This could be as well the repository service, but we have chosen here the designer service because this one comes along with the repository service already. Within this repository service, you will see available repositories which have been created already within your customer organization. For today's use case, we will create a repository from scratch. So we will call this one test MTE, testing repository. Once I have created this repository, in the background, everything is persisted within our Git-based repository and gets created right away. In order to connect to the repository, two things are needed. First of all, the repository itself, but as well the access tokens, which can be managed on the right upper corner, where you can create tokens which are then valid for a certain period of time to exchange when configuring from an endpoint which is not in the web. I'll call this one Markus. It's valid for 3 months. I generate this token, and once it's created, I can use it from any given source. Okay, I have not copied the token, but that's okay. I'll invalidate it anyway, just after this session. Okay, so within the repository, we can now see we have 0 projects and 0 mappings. We'll change that now, and we will create our first mapping project, which we will then hand over to Carsten as part of his task to create a mapping from scratch. We call it mapping demo for the moment. Please add maps and create. So now the part in the web is already finished for the moment. We will now hand over to our backend developer, Carsten, to create the mapping. And after that, we will come back to the web UI to show you how to manage existing mappings or to create mappings from scratch. So Carsten, please take over.
Okay, I will take over the screen and start from the same point where Markus stopped, essentially, which is the repository service. Before I jump into the standalone or FAT client, I need to first create a token also for my user on the demo system so that I can clone the repository on my standalone client later on. To do that, I follow the same steps as Markus just showed. Go to access tokens and create a new one. We leave it at the default setting for 3 months and call that, give it a name accordingly. Generate a token and copy the token into the clipboard so that we can use it later on when actually connecting to the repository. So now we leave the web-based part and jump into the developer studio, the mapping designer. As you see it here, maybe familiar looks. has been available for quite some time. And here we can connect to the same repository that Markus just shared and import the existing mapping project and start working on that. In order to do so, I will go into the Git repositories and clone the one from the repository service and paste the credentials. The URL is available on the repository service itself, where I need to go back one level and say copy URL on the desired repository. And once I have that, I can copy paste it into the mapping designer, confirm that. And after a quick loading time, I see the available branches. So as of now, only the master branch is available. However, that is subject to change in the future. Confirm the settings here. And I have the repository also cloned to my local machine. From here on, I can then import the existing project or the project shell rather into my mapping designer itself. As of now, it's entirely empty because Markus set it up in such a way. We did prepare for this demo a somewhat simple mapping from an inbound EDIFACT transport order to a JSON format. For example, if the ERP interface is a web service behind that. So we prepared the schemas and the underlying test and reference files because we will create a mapping with the AI-assisted approach, meaning I won't spend time creating a mapping from scratch entirely. I will let the AI assistant do most of the work for me with the data-driven mapping approach. The data-driven mapping approach, as the name suggests, needs, of course, data. For that, we also prepared 3 input and reference files, which belong together and may simulate a existing mapping or a existing flow from an older system, legacy system, or an existing flow that needs to be migrated. That is our starting point here. Once we have that available, we have a new entry in the wizard when we say new mapping generated by AI. First, we have to give it a name accordingly. And then we need to select the source and target schemas which we want to use. In this case, we have a inbound EDIFACT if-bin D01B message on the source side. On the target side, a simple JSON schema. Once we select those, we can select the input and reference file that the mapping should replicate. By default, the pairs for input and reference files are matched via the given file name. However, you have the option to specify additional file name patterns if you have already an existing archive, for example, from a process flow. So you don't need to go through the entire archive, rename the files that they match by the name. There's the option to do it after the selection screen here if needed. You'll also see here a estimation or an guesstimation on how many tokens the input files, reference files, the general overhead of the request to the AI, and also the prompt all together may consume. This is important because for larger files or larger amount of files, you may exceed your limits that you have configured. And for this, we have something in place which is called chunking, where we split up the input and reference file pairs into individual chunks, so we stay within those context or token context limitations. You see also here which model will be used for this request. For the demo purpose, we use GPT 5.2 because it's a bit faster, and the scenario we prepared leads more towards a simple mapping setup. So we will achieve most likely decent results with this. And we also see here that we are well below our configured token limitation. So all that is left to do is click the finish button. And then the AI assistant on the right-hand side will start to process. This will trigger now a bunch of different processes in the background. First of all, it will start a iterative process. So the input files, the reference files, together with a prompt on what to do, with a rough explanation of the mapping language, is sent to the AI, the language model. And after each answer, with a mapping code suggestion, the result is audited in multiple steps. The first one is a super simple one. Is the mapping even compilable? So does the mapping even compile with our language behind it? The mapping language we use is mostly based on Xquery, XPath. However, sometimes with AI, we have to keep it in check so it does not get too creative, and we don't want to end up with mapping code we cannot execute. Once this first step with compiling a mapping is passed, the audit step comes next, where with the suggested mapping code, the input files are converted and the resulting output files are then compared with the reference files provided. And when comparing the reference files with the actual output, the score is determined, which is an indicator on how close are reference and output actually. If it is an exact match, the score will be 100% obviously, because then the output and reference files are matching exactly. And then for each difference, there's a penalty applied to the score, meaning lower score means less common matching file pairs. Higher score means there's only minor differences, or a difference occurs multiple times, but it's always the same one. Score and also the amount of repetitions within the cycle can be set in the settings. For the demo now, we set it to 100% and to a maximum of 5 iterations to also speed up this process. You see here in the resulting report, we spent now around 1.5 minutes in total, and we missed our threshold of 100%. However, again, 100% means that output and reference file are an exact match. Additionally, if the threshold is missed or less than 100%, the report will also have an overview of the differences that the highest scoring mapping still has in comparison to the reference files. We have the aggregated view in the report, which shows which differences are there across multiple files, and a detailed result, which is based on the already existing regression test capabilities of the mapping designer, and where every difference is listed that is still resulting from the mapping. For example, if you take a look at the aggregated view here, we see that there is a field called creation date time, which does not match between the generated output and the reference file, and that difference happens across all file pairs. So that's for example, a strong indicator. There's a general logic that is not correct by the generated mapping, However, when fixing that, you will fix that for all file pairs. And here it's most likely a current datetime or a timestamp that is not yet correct working, or again, the timestamp is most likely different for all reference files. So that's the difference that may be expected actually at some point. The generated mapping itself is then also opened directly within the mapping editor and can be executed within the standalone client. If we add the test files here, you can run it and see the resulting output, again with minor differences here compared to the actual reference file. And for example, if we were now to correct the mapping, we could go through the mapping and fix now the open issues by going through the mapping code. Additionally, we also have in the mapping designer the AI assistant, which we can use for different purposes, not only for generating mappings on input and reference file pairs, but we can use it in a context-sensitive way with the integrated AI commands, where we can tell the AI to explain our mapping code and push that even so far as to generate a short mapping description or specification based on the provided mapping. So this will now try to explain some crucial points in the mapping, some common pitfalls, and also, most important, the assignments between source and target field. Within a given format. So this will run now a bit in the background, and then we can open, have a look at this one, at this result here in a dedicated view. And this will be the created mapping documentation based on the mapping we just selected, with a bit of preface, bit of introduction text, technical background. Again, XQuery and XPath is the language that we rely on for the transformation. Some hierarchy explanations in the mapping that has been found, and most importantly, the most important one, the field assignments between source and target, so we can actually see what the mapping is actually doing without a deeper technological background or without looking at the mapping directly. On top of that, the AI assistant can also be used as a simple chat window or chat command. For example, if I were to ask, how can I sum up the quantities XQuery, and it will send the request with a given system prompt and answer based on, again, the XQuery XPath functionality. So here I have the option to change my mapping code or use the functionality provided within the mapping designer to understand and also extend the existing mapping with the usage of AI. Other than that, the part within the standalone client is here almost finished. So I did create now the mapping with the help of AI from scratch based on input and reference files. And now the last part to do for me is to upload the generated mapping together with the input and reference files and also the use schema to the repository so that a colleague, in my case Markus, can take over and work on that in the web-based version in the Mapping Designer service. For that, I will just take everything that we added in this mapping project and commit it to the repository as you do with any other Git-based repository, and hand over to Markus so that he can work on the mapping further.
Thank you very much, Carsten. All right, so we are still in the same spot where we have left, which is our mapping project with 0 mapping. So first, a couple of words. Why are we showing this now in 2 tools? So currently, in the last couple of months, we were heavily investing in the AI area, and our fastest return of invest was doing it in our local engine. So we had a nightly build running to create a tool each and every day new, so we can test what we have implemented. And now we have a status where we say we can now move everything to the web. We restify all the services like the agent, like the tooling we have implemented, regression testing and all of that. And now this is being transported to the web. All right, let's refresh quickly the interface here, which we now should see indeed one mapping. So that is correct. We can now open up the mapping project, mapping demo. And in here, we now have the predefined mapping. Of course, we can create a mapping as well from scratch within our web-based tooling. So here we could, for example, say now we want to have the vice versa mapping from JSON to Edifact. So we would then select the source and target schema vice versa, add some sample data and whatnot. The cool thing is now, sequentially, we will add new features. Like, for example, we could upload a schema file in here. As well, we could generate sample data using AI. So all of that now is being added to the web as well. And you will see a lot more helping tools which make your life around mappings way easier. So for the moment, let's just save the mapping. Now we have it from the JSON to the Edifact. And when we open up this editor, we will see a source and a target tree, like you would expect. In addition, we have the visual editor and our code editor. So we are not hiding the code editor. So purposely, when we came up with our BIS Mapping Designer and the BIS Mapping Designer language, we said we are going not fully no code, we are going low code, which now we have already a big benefit because we selected a open source standard language with XPath and XQuery, which is capable to be created, being changed, and being interpreted by AI. And is easy to read. So a more like what you see is what you get language, which does not hide any features behind some not transparent functionality. In order to create a mapping, of course, you could go the classical way of doing a drag and drop, and each and every time you are doing so, on the right lower corner, you would get the updated code simultaneously. So as you can see, pretty straightforward. Now let's go back to the mapping, to the one which Carsten came up to see a mapping which is close to reality, or basically is reality. And here I can show some couple of features. Next to our source and target tree, we as well give you the option to parse the data or add data, so test files, to each and every mapping. In this case, we do have the 3 mapping data pairs, or the source files we have used to create a mapping. At the same time, they are loaded as sample data and therefore being passed directly onto the source tree. So this now fills up your message tree with some life, which is easier to understand than just a 0004, which typically is hard to interpret for someone who is not speaking EDI or Edifact natively. Of course, for everybody being really confident with EDI, we always offer you as well the raw data view. If you are feeling confident and you are faster when reading the source data, we as well give you this option too. We do not only parse the source data, but as well as Carsten already created a mapping, we as well have our target data already being passed on the target tree. And each and every time you are changing code, it will update your target tree automatically, which gives you a feedback whether the code you have applied or the field you have mapped is actually a valid one and you did not destroy your whole mapping. So when we, for example, now click on the code qualifier, it gives you 3 or 4 basically different views. In the middle, we have our target, which we have selected. On the left-hand side, we have the corresponding source field. On the right-hand side, within our visual editor, we have the path name, and on the right lower corner in the code editor, you see the corresponding line of code which belongs to this data field. When we now change this, for example, when we click on here and say we don't want to go source data and we don't want to go function, we just say value, and we exchange this data, for example, with a fixed text, we would exchange it here and add test, for example. And when we now apply the code, it automatically updates our target tree already, but it not only updates the target tree, it as well updates the raw data, which is being passed onto the target tree. And simultaneously, the visual editor changes, of course, and the code changes alongside. So in the visual editor, of course, you cannot just add text values, you cannot just add path, but as well, you could, for example, say, okay, we have now a statement here, but instead of having the full 0010 field, you would, for example, wrap this with a function and say, okay, I only want to have the, I don't know, write 3 characters, for example. We are now searching for a write function. In this case, we say add, and now it pops up or it overlays our field, which we have selected as an input. And now we do select a length we want to have. In this case, it's a number, and this number, for example, would be 3. And when we now check the target, which used to be the full-blown 0924, whatever, and we click on apply, this now automatically changes to 420, and on the right lower corner, you see the corresponding code being changed. So this is now how you would finally change the mapping. And of course, we did some more to this. So if you have repetitions on message, you can click through them. So you don't have the full tree available each and every time. You have this on source, you have this on target as well. Even variables are being shown. So all of that is already implemented, available, and ready to be used. And then when you click save, everything is automatically committed in the background to the repository being available for our developers or for your developers. If you want to interchange, for example, or exchange information together with a backend or EDI admin, you can as well go onto each and every field and add a comment here saying change to fix 12, for example. You can apply, and once this is done, it has been added to the code, and we will not only make comments, but as well to-dos in the future. So you can actually have check marks to cross off then in the backend for a developer to change everything you are telling him. So this is now an easy access to a mapping to make it very transparent, not only for the business, but as well for support to do some quick testing, quick debugging. And the next couple of weeks, there will be significant changes, especially in regards to AI, where we add the SIA now to the mapping designer, which we have already in our IWS in the integrator workspace, a context-sensitive helper agent. Like Carsten already showed, we will add the mapping generation to the web in the next couple of months as well. And this is indeed just the beginning. But all the cool stuff, as I would like to call it, will happen in the future in these services. All right. Speaking of services, then at one point, as we have already seen when Carsten was creating the mapping, he already had a regression test being created. We will in the future persist this file to make it available for you to rerun those regression tests regularly, either in the night or in every change, so that you can see when you have changed something, there is no cross-site effect on other parts of the mapping, for example. So to make this easier executable and easier and more transparent for you as an HTML file, for example. Alongside with that, the deployment is currently available using a zip file, but we will add this one as well with a direct deployment in the next couple of weeks, not only to cloud-based systems which are hosted in our environment or in AWS, but as well on premise as well. We are using an existing endpoint for this, which we are already using to exchange monitoring data, for example. So this in the future will allow mapping deployments as well, making it possible for you to then set up a deployment pipeline, defining what has to be done, like mapping deployment, generation, mapping regression testing, and then a deployment to a certain target system. For the moment, you can create such a deployment zip. You can add a version if wanted, and then you can click on create. You are getting presented a mapping file, which you can then upload to any given BIS system of your choice and deploy it either there on a test system or on a productive system. All right, so this is the current state of work. Both services, as said, are available as of 1st of July in their current functionality. But as said, way more to come. And in autumn, we will have another webcast session where we will surely present already some updates on the existing capabilities on top. All right, so when we now go back to our slides, I guess I've already taken most of the evolution parts already before the slide. So it's a data-driven mapping development, the AI-assisted mapping experience, where you get guided through a mapping. Then, of course, repository as the single source of truth, quality and validation, operational excellence, which will change. And in addition to that, transparent repository and collaborative mapping development. Okay, so Sandrine, that's it basically from our end. Question would be, is there any question from the audience already?
Yeah, there are a few. So first one, I think you've mentioned that already, but maybe again, can I also use the web-based mapper if I have an on-premise BIS installation?
Absolutely. So it's an on-top service. It's a central designed approach, and the data you are creating there is fully compliant with your on-premise installation as well. So you can transport your mappings, which you are creating in the web as well to your local system, and you can connect from your local on-prem system to the cloud repository as well.
And does the designer service require a specific browser? We are only allowed to use Edge at our company.
No, there is currently no known limitation. So we've tested this with all the major browsers because we are very aware of limitations within within certain companies in regards to what kind of software is being used. But the general ones are supported, like Edge, Firefox, Chrome, Safari.
And where do we get the message structure for the mappings?
So there is multiple options. So the first one would be you are creating it based on sample data. You can upload schema files like XSD, YAML files, or you can get them from our asset catalog if needed, where we have, for example, Edifact X12 and 40 years of experience, I would say, in regards to the many various formats up until to the German automotive VDA formats.
Okay. And at the beginning, you defined the mapping project through the managed service. As I understood it, the Git repository for this project was set up in advance. And that's followed by two questions. First one, is it possible to configure more than one repository, for example, one per criterion?
Yes. So indeed, there were, I had multiple things. So first of all, there was an existing repository already linked to this customer account. In this case, it's our the customer portal of the BIS Hub demo, and such a organization can have multiple repositories. One was already existing. I have created a second repository. There is currently a limitation of 10, which could, of course, be extended. And within such a repository, you can have multiple mapping projects. They don't have to be created solely using the web interface, but as well they can be created using your local mapping designer engine as well. Or you can use your existing Git and transport everything to this repository as well. That would be an option to go for too.
Okay, and second question referring to that was, how does the CI/CD pipeline work?
All right, so what we are currently planning is that we start with a limited set of functionality to select from. So we are limiting this whole world of CI/CD functionality for the moment to, let's say, standard functionalities, to standard plugins. So this could be, for example, versioning of a mapping with a given versioning format. This could be a deployment to a certain endpoint. This could be a deployment zip creation. This can be a regression, executing a regression test of a mapping project. This could be as well creating a documentation, uploading it to a certain endpoint, like a Jira task, for example. So this is all standard plugins and standard functionality we will offer, and this will incrementally be enhanced. I'm not yet sure whether we do allow custom plugins to be executed, but surely it will cover a lot of the standard functionality of such a CI/CD pipeline, and of course the setup of when it's being executed or if it's a manual run to be executed.
Okay, thank you. Next question. In the case of the full managed service model, where mappings are supposed to be created by Seeburger, do we still have the possibility to use the mapping designer service?
That's a very good question. I think technically that is possible. Not yet sure whether it is already been completely thought through, but basically we are storing the mappings of a full managed service customer as well in a Git. And we could then, once the service is booked, being exchanging this to the BIS repository service. And then as well, we can connect to the same one from internally as well. And we can change this more like to an iPaaS model or to a transparent, what you see is what you get model that a customer can change and or at least view, maybe just limiting it to view for the moment of what is currently implemented in such a mapping. Yes, that could be, of course, an option.
Okay. With AI mapping, can it discover and convert qualifier codes between different file types, or do you have to do that manually?
So a recognition of codes and qualifiers is absolutely possible. So for example, if you have a EDIFACT to ANSI or EDIFACT to CXML, where we have a lot of qualifiers as well, the AI can indeed recognize a qualifier transcoding. So switch cases, for example, are already possible output of the AI mapping transformation, and this is indeed being recognized. So yes, it is possible, even automatically.
Okay. Can it understand and concatenate fields depending on several input fields?
Absolutely, as long as it is kind of transparent within the data. So if you have, for example, a field being sourced from 2 or 3 or more source fields, it is indeed possible to recognize this, and then it would default to the concat or concat function we have in place and source those with a corresponding concatenation character, or just link it after the other. Yes, that is possible and is already being tested and evaluated.
And is it possible to add some input parameters for it to handle?
Currently not. What we are currently planning is to enrich the test data pairs by additional data like the legacy mapping source code, for example, XSLT mapping, big mapping, but as well a paper map, which we then format to Markdown to be interpreted. And give this one as an enrichment to the AI capability, to take this in cases where the AI cannot recognize a certain field solely on the data. It can fall back to this data then and get it from there.
Maybe as an addition to that, we also plan to include the human in the loop at some point. So when there is a place or a field mapping that relies on a lookup table or any other data that is not visible within the given input and reference files, that the AI will recognize this, which it already does today with a to-do. However, it will then ask you as a human for feedback how to proceed with this point here. And this is also relevant, for example, when using SQL or lookup tables via map files, because those map files aren't, purely speaking, visible within the input and reference files. However, the AI will sometimes try to implement those cases with a huge switch case, but add also a comment at this place, indicating there's a lookup logic most likely there in the legacy code.
Okay. And how do you use this AI tool to work with SQL tables?
So currently we are not supporting in the tool mappings being solely read or written to a database. So if the source or the target of a mapping is purely SQL, this is not working because we have no data as such or no file as such. This would rely then based on the additional input of the legacy mapping or mapping description to create a mapping from such a source.
Okay, and if input and output files don't have the same structure, can it handle that?
Yes, it can. In the background, we have a mechanism to parse the data against, so we support each and every file format as long as we have a schema, because in the background, we are automatically converting everything to XML, and this is then our source of matching the data within the AI. So the pattern matching is always on XML based. The good thing is that the language we have in place doesn't divide between Edifact, ANSI, and other formats. We have the same language throughout our formats, so we can do it based on XML and then go back to the original schema and have the same code or same assignment of fields in place there.
Okay, and finally, can the AI learn to log specific data to your logs?
Not yet. So we are not supporting training or logging or storing or parsing data. However, the idea is indeed to go into a more like RAG approach where you can store your existing mappings or your existing mappings are available to learn from those. If you want to have things to be added, it would be a user prompt being added to our standard prompting, then enriching the mapping generation by a specific user prompting.
Yeah. Additionally, we rely on an API endpoint essentially for the AI mapping generation. And for our demo, we use now a proxy for our Azure-based service. However, if you have the infrastructure and can provide the API endpoint for your infrastructure, you can use also the infrastructure and your language model for that one, which then could also include the additional documents or specific learnings to your business processes.
Okay, that was the last question actually. So thank you for your insights and your answers. And thank you to the audience for joining us today and for your interest. Few more things before you leave. I really want you to invite you to the next webcast, not of this BIS Hub series. We'll continue that in autumn, but we got another session of our quarterly BIS Innovation and Optimization series on July 29, the English session at 4 in the afternoon Central European time. You will find the free registration on our website. Then I also wanted to invite you to our Seeburger community where you can discuss and ask questions to your peers, to other users, and of course to Seeburger experts. And then finally, before we now close this webcast, after that you will be led to a website where you can answer a few quick questions telling us how we did today, what we can improve next time, what went well. I would really love to hear from you so we can improve this for upcoming webcasts and align this to your needs. And yeah, thank you again. Thank you, Markus and Carsten. Thank you to the audience, and I hope to see you soon again. Bye.
Thanks for having us, and see you soon.
Thank you. Bye bye.